So 26th question is, if the sum of lengths of the hypotenuse and the side of a right angle triangle is given, so that the area of the triangle is maximum when the angle between them is pi by 3. So we have to show that the area of the triangle is maximum when the angle between them is pi by 3. So let's jump into the answer. So the solution will be given x plus y is equals to k. When this is given that x plus y is equals to k, area of triangle is equals to 1 by 2 x in under root y square minus x square. Let's assume z is equals to 1 by 4 x square bracket y square minus x square. So this is the right angle triangle and this is the area theta. We are supposed to prove that pi by 3 so that the area will be maximum. So after that, assume, let's, yeah, we can write it as 1 by 4 x square k. We can put the value of y k minus x square minus x square. We can further solve it 1 by 4 k square into x square minus 2kx cube. After that, we can just differentiate it. After differentiate it, we get 1 by 4 2k square x minus 6k x square, which is equals to 0. So that we can write it as k minus 3x is equals to 0. So x will be x is equals to k by 3. So x plus y minus 3x is equals to 0, or we can write it as y is equals to 2x. Further differentiating it, we get d square z by dx square is equals to 1 by 4 2k square minus 12kx. So putting x is equals to k by 3 in this, we get 1 by 4 2k square minus 4k square, which is equals to minus k square by 2, which is less than 0. Area will be maximum for 2x is equals to y, but x upon y is equals to cos theta. So cos theta will be is equals to x upon 2x, which is equals to 1 by 2, which is theta is equals to, the theta will be pi by 3. Hence proved. Thank you.